So yeah, I'm Francesco, founder and technical director of Erlang Solutions. Why am I here? Probably because I'm paying for my sins, I guess. I was on the team which worked on the R1 release of OTP. I think the year was 1996. I had just finished my master thesis at the Computer Science Laboratory with Joe Armstrong, and had moved over to Erlang Solutions. Not Erlang Solutions, that was a few years later, Erlang Systems, which was Ericsson's training and consulting arm. So, honestly, I didn't quite understand the impact of what we were building or doing at the time. I think my focus was, I was the student straight out of university who thought he knew absolutely everything until he learned something new. I think we've all been there at some stage in our lives. And I basically put kind of all of my memoirs in a book called Designing for Scalability with Erlang OTP, where I basically, once I actually figured out what it was we were building, 10, 15 years later, I documented it all in there. And I'm really, really excited to have Andrea Leopardi with me today. Andrea, why don't you introduce yourself? It's the first time we're doing something together, which is about time, yeah.
Hey everyone, so I'm Andrea. I'm in Italy right now, and I'm here, well, because I read Francesco's book, first of all, so I learned about OTP from there, actually, a few years ago. And I'm also here because I'm Italian and Francesco's Italian, so we obviously automatically know each other and, have to support same nationals.
So we'll be giving you the recipes for the perfect carbonara. And
this is a
no,
it's a recipe, AMA, yeah. And I'm here because I think I'm here because I'm a part of the Elixir core team, and I've been in the core team for 5 years now, almost 5 years, and I've been doing a lot of. I've worked with Elixir all professionally for a little bit more than that, and so I built a bunch of stuff with OTP and the Beam.
Yeah, and I think there are slightly different approaches to how you do things in Erlang and in Elixir. So and also I might have the experience with OTP behaviors in Erlang, and Andrea has all of the experience with OTP behaviors in Elixir. And there's also a slight different definition of what OTP is in between the different communities. What I just wanted to guide you through is very quickly kind of come up with the historics. Why was OTP invented? So just maybe 5 minutes, after which hopefully that will set the scene, and you can go in and ask us lots and lots and lots of great, fun, hard questions. Is that okay? It's an Ask Me Anything session. So hopefully you've got the question. So Erlang was invented, they started working on Erlang in the late 80s, and in 1993 they started on the first commercial, in 1992 I believe it was, they started on the first commercial project. The first Erlang commercial project was the mobility server. And in conjunction with that, I think they realized that Erlang was a programming language. It had some really, really great features, but if you wanted to do software design, software development, you needed a bit more than a programming language. And so, this is where they set up a team which was started working on something called BOSS, the Basic Operating System. And what this team was looking at was, ready-built applications and libraries. So, what is it which you can use and reuse? When a language is just invented, you've got no libraries, you've got no reusability. Now, this was early 90s, so reusability, I think, you tended to reinvent the wheel a lot. It was probably 7 years before the term open source was coined. It was and I think a lot of the components you bought were all commercial. So you needed design principles. I think telecom systems were very complex. They were they had to be fault tolerant, and there were some design principles which could be reused across projects. So they went in and how do we get these design principles put them into libraries, which can then be reused. Methodology, I think, an ugly word, but what approach to actually take, I think, is probably better. When developing these systems, and what tooling do we have? I mean, software upgrade looks great theoretically, on paper looks fantastic, but when you need to start doing it in practice, I think it starts getting much more complex. So I think a lot of tooling was done, and keep in mind, your tooling back then was very, very different from your tooling today. So what you did with your tools back then is you hooked into larger tools. So yeah, I think very typical to enterprise development. You get told what tools to use, irrespective of programming language, and then you've got hooks, and you basically hook into this wider ecosystem. And so this project to tackle these issues was started in 1993. So this was more or less at the same time as the mobility server project, which was started. And it was, the result was the basic operating system. There was a team in Orange County, California, headed by two former colleagues. One of them is still active, semi-active in the community today, Lennart Öhman. He was the one who invented all of the design patterns. And in 2 years later, 1995, Lennart Öhman flew back from California, and they merged the basic operating system and Erlang to form what became OTP. So there was the first OTP project which I worked on, which was started in late 95 and then moved on until 96. And this merge happened in conjunction with major Erlang projects within Ericsson, so projects with 100+ developers. And yeah, OTP, a very, very unfortunate term, but it was at a time when everything, open was a real buzzword within Ericsson. So everything had to be open. You walked in the corridors and there'd be posters of open landscapes, of fields in Ireland, we struggled, so it was there mainly to please management who were funding this. Let's be blunt. This is not being recorded, so I can say that. Telecom had absolutely nothing to do with telecom, but again, those funding this were, Ericsson was a telco company, and so those funding this, for the, open telecom, sounds great. And the only real term was platform. It was a platform, which was basically the middleware, which you need when doing large-scale software development. And yeah, this is a little visual of it. And the real focus, and really where there was a huge impact, was within software development, was the system design principles. And that's really, when we talk about OTP today, we mean the system design principles. And what they did is they described the software architecture of a node in an Erlang system, but also in a distributed Erlang system. So, and you needed to follow these design principles and rules for a variety of reasons. But A, because Ericsson projects, they'd staff up and you'd have 100 developers working on the same project, often in your geographically remote places. So, by using the same design principles, you're then able to move subsets of the code from one place to another. And there was very, very little of the reinventing the wheel. And then, by following these rules, the tools, you could take shortcuts, they'd be compatible, and maintainability also became key, because it became much easier, because you didn't need to focus on the business logic and not how the business logic handled everything. And so, and this is, I think, what we know today, where we've got applications which we use to package supervision trees, and supervision trees consist of other supervisors whose task is to start and monitor processes, child processes, and workers. And workers are those who actually do the work, the behaviors. And supervisors and workers, we break up the code into generic code and into specific code. The generic code is what you use from one project to another. The specific code contains the business logic which you work on. And your standard Elixir and Erlang nodes or systems will consist of the hardware and operating system, the Beam VM together with a set of applications. And a node will consist of a bunch of loosely coupled applications, which you can reuse, each containing their own supervision tree. So a way of isolating failure and handling failure. And yeah, each application behaves in the same way, irrespective of if you've written it or if it's an open source library or part of the standard libraries. So yeah, so this is kind of the introduction to setting the scenes. Now, does anyone, and I'm wondering if you could post any questions you might have in the chat. Else, I've prepared a few questions and I'll ask Andrea as well, and yeah, and he can ask me a few questions as well. But we've got a few questions I see here in the chat. So one was from Brandon. Why don't you unmute yourself and ask your question? Are you there, Brandon?
We can't hear you, Brandon. Mouth is moving.
Can you hear me now?
Yeah, perfect. Okay. Yeah, great. Okay, hi there.
So given how Erlang was built 30 years ago and all of these OTP design principles were kind of conceived of then, what modern use cases and problem domains that OTP are being applied to today, which of those surprise you a lot and which ones don't surprise you at all given those design principles?
So I'll give my view and then I'll pass over to Andrea. But what surprises me today is how they were able to predict orchestration, how they were able to predict the whole notion of dynamically scaling up and scaling down clusters. They didn't get everything right. So for example, they've got Mnesia database, which again was, I think, one of the it was the first distributed database I've ever worked with back in 1995, open source in 98, so way before the whole NoSQL hype started. But with Mnesia, you were able to add nodes and remove nodes on the fly in a way which wasn't too user friendly, but you're still able to do that and automatically get access to your data. So see it almost as a Redis for the Erlang ecosystem. And I'm seeing this approach today, with Kubernetes, with containerization, but I'm seeing it in a way where we've actually taken a few steps back, because what we do is we kill the whole container instead of creating different layers of fault tolerance. So you've got a process, which is your first layer, then you've got your supervision tree, which is the second layer, the application is the third layer, your node is the fourth layer, then you get the container. So I think you've got quite a few levels you can escalate before you need to kill your container and restart it, and this is completely disregarded today. So we'll eventually get there. And the whole notion of para-virtualization as well is something which they write back then, where you're running as close as possible to the bare metal. Back then it was necessity because you were running phone switches which handled millions of subscribers on 32 megs of memory. You couldn't, and then the more you needed every single point, all the memory you could get your hands on, and as well as every last CPU cycle to handle those loads on such weak memory. And along comes containerization, virtualization. The more layers you add between your VM and the hardware, the more memory you consume and the harder it gets. So that was the thing which I think surprised me the most, that we still haven't reached the level and power which they had envisioned that we were doing some time ago. Imagine when instead of spinning off a Docker container, you can just spin off a Beam VM running Elixir or Erlang, which has no layers, which is just on the bare metal. So almost see it like you'll be using Kubernetes, see it as using Kubernetes, but not being aware that it's actually being used. I don't know if that makes sense to you, but it's yeah, it's going to be in the program. You know, this whole, you know, scaling up and scaling down is in the programming model. You know, when you're developing in Erlang and Elixir, it's already in there. It's already catered for. And yeah, so, but yeah, we don't have that infrastructure, you know, today in there. Andrea, what about you? I mean, so
Yeah.
I mean, the question is, yeah, what modern use case and problems domains of OTP do you find most and least surprising to see?
Yeah, well, the first disclaimer is that I heard the word Erlang, I think like not very long ago, maybe 7-8 years ago. So I don't really have the context to say, oh, this is something I had no idea could be done with Erlang, because everything is that's being done now is how I know Erlang, but at OTP. But I can speak for the least surprising use case to see is like most of the use cases where it's being used that I kind of hang out around, which is like web apps, you know, and doing embedded devices. Well, embedded devices was the original use case, right? So that makes sense. I'm speaking mostly for Elixir because that's a sphere that I you know stick around with. But seeing this used in embedded devices kind of the natural fit, because that's where it was born. Seeing it on like real-time web apps is also very natural fit, I think, because of how, you know, the paradigm and the architectures mirror the ones for telephone switches, right? The original where Erlang was born, which is, you know, like all these connected clients that are, you know, connected to each other through some brokers and, you know, some servers, which is kind of, you know, the whole WebSocket thing that launched Elixir and Phoenix quite a lot. So that's not a use case that surprises me for OTP. And so the thing that surprised me is that I really don't like I don't know. I don't think I have the context. One thing that I agree with Francesco on is that it's crazy how much they got right. It's really like unsettling that we're going back to all this stuff, like just exactly doing what, you know, like this stuff was built for what we're building now, at least, you know, in web and in the embedded devices worlds. And the only thing that I've never quite felt like a great fit is the hot code reloading, because I think it had more sense back then when you were, you know, like you drop the call if you stop the server, right? So it's like a user experience problem. And now the focus shift, like when we move to the web and we move to this terrible connections all around, like, you know, you have your phone and like the connection drops constantly, you know, your packets are dropped constantly. This is like a pretty you know, unreliable infrastructure that we are on right now. And the hot code reloading is not as necessary there, I always felt, because you always have to build applications that are resilient to failures all the time. And there's this like whole, you know, philosophy of offline first, which is that now is the only way you can build like reliable applications that work everywhere, right? And so the hot code reloading thing feels like always felt from the modern perspective a bit like superfluous, because like why would you reload the code live and go through the whole trouble that it takes, because it's definitely trouble, you know, rather than, you know, shutting down and redeploying. I think it's maybe less I don't know, that's something that lost its value over time, maybe. But maybe Francesco can speak more about this. I've always been curious about this. I've never actually seen it used you know, very well in modernly, you know.
So, you know, you know, when it comes to hot code reloading, it's I'll give you an example. There was a switch they were upgrading in a city far away. Countries, cities, names have been obfuscated to protect the innocence. But this switch, it was an XT301 switch, had been running for about 3-4 years without any issues. It was switching all of the international calls for a carrier, and after 3 years, basically it was, the XD, I think they released about once a year. And after about 3 years, they came up, they went in and said, hey, we've got, we're not supporting this version of the switch anymore. So you have to upgrade. And so they went in and they upgraded in succession. They went in and upgraded the switch in succession. Because it was fair to upgrade 3 versions of what is already a very complex switch would have taken too long to get right. So this upgrade required a reboot of the system, incredibly rare, and they went in and rebooted the system on one of the nodes. So all of the traffic fell to the standby node, which became the primary node. And once they'd rebooted, they couldn't get that node to restart. And at that point, they panicked. So they rebooted the other node, which they couldn't get to restart either. And they couldn't get it to restart either. And at that point, the outage lasted 7 days. For 7 days in a city with millions of inhabitants, you couldn't make any long distance calls on a particular carrier. I had a colleague of mine went in and smuggled replacement boards. He flew, the first line support, second line, third line support. He jumped on the first plane, flew in, hiding the boards under his trench coat, because if they were to FedEx them, they would get stuck in customs. So he actually brought them into this country, smuggled them into this country, pretending he was there on vacation or whatnot, and replaced them. And what they discovered, with this upgrade was that they had, the boot sector on these Solaris machines was the external sectors of the disk, and the system had not been rebooted for 3 years. It was running, it had not been rebooted for 3 years. So 3 years, the hard drive was going backwards and forwards, and this thin layer of dust had assembled on the external sectors, which were the reboot sectors. So when they went in and finally rebooted it 3 years on, the disk went in and basically, the head got stuck on this thin layer of dust. And these are the types of problems they solve with live upgrades, which they face. And the system may never fail, may never stop. And so, when you get failure, it becomes huge. And the whole live upgrade was a way of ensuring non-stop continuation of the system. Not only, even at the time when hardware was extremely expensive. So you try to really having standby standby hardware was a luxury. You ideally wanted to use all of your hardware at full capacity, so you couldn't deploy an extra. Doing it the way we do it today, we deploy a new container and then you kill the old container, meant having an extra CPU, and that just didn't exist. So that wasn't possible. So that's where software upgrade happened. Personally, if you design and think with software upgrade in mind, it's not that hard. And in 90% of the case, you're doing continuous integration. You can easily do continuous deployment as well, and test it, and have kind of live tests, which tell you, if it works or not. So it's something which, in my view, can be automated, but often there's a cost associated to it. So and so sorry for using management terminology here, but you need to do a cost-benefit analysis. And say, does it actually, we're actually saving the money? And most of the time, you've got a single installation, it's a startup, it's you're not running in tens of thousands of installations. It doesn't make sense. So you can just reboot the system, you have a 1 minute outage, and then you're done, you're running. Yeah. So we've got another really good question. Let's see, we've got one by Don Barlow. Are you there, Don? Yeah.
Yes, I'm here. So I'm similar to what Andrea said, that working in the web sphere and deployment with Kubernetes and AWS, platform and that kind of stuff. But that's always kind of bothered me a little bit. So how, just theoretically or whatever, how could we not even deploy without Kubernetes at all? Because one thing I see is like, if I want a node that supports one particular purpose, but then all my other nodes are just kind of to scale to support my web requests, I don't necessarily, when I do a deployment, I'm deploying that whole thing on a Docker container. So it has an instance of that one node on all of those individual things, if that makes any sense.
It does. So, and Andrea, do you want to answer? Do you want to answer this one? And then I've got something I want to share as well. So,
yeah, it's a good question. I don't know, instinctive answer would be another question, which is, do you want a system that runs Erlang exclusively, right? Like, to me, the value of something like Kubernetes and Docker is that you can have a very heterogeneous system where Erlang and Elixir can be a part. So if the question is more like how can you have a situation like yours where you have like a subset of services or nodes in the system that are Erlang, and you want to make those talk to each other, and then the rest of the your service architecture is what is deployed through like orchestration, and how can OTP be extended for doing that? Then I don't know. I have to think about it.
Okay, so I've been doing a lot of thought about that, and my view there is what you need to do is hide it. You need to create a new programming model where what you do is you basically have it becomes a kind of callback based client server approach, where it doesn't matter what programming language the client is written in. It could be in the browser JavaScript. And then on the server side, you've got callbacks where your state, it's session-based, and your state gets automatically then distributed across clusters of machines. So, what you're doing is, with this approach, you're abstracting away Kubernetes, you're abstracting away the network, you're abstracting away locality, and moving all of this into the programming model and into a domain, which is not controlled by the programmer, but controlled by the operational team and by the architects. And I think there's a keynote I did together with Veronica Lopez. Veronica is part of the Kubernetes core team called The Future of Programming, where we describe this in more detail. I've posted the link to this in the chat. And we've given this talk a few times, but I think the best one is the one we did at the Reactive Summit, when we keynoted at the Reactive Summit. And what you need to do is you need to abstract, basically, think of an OSI model for distributed computing, where on the top, at the bottom you've got your network, and then you've got your hardware, your operating system, your virtual machine. And then on top of the virtual machine, you've got your distributed patterns. On top of those, you've got the programming language, and then you've got the programming model on top of that. And it's so all of this functionality you're describing, imagine that in an extension of OTP in a programming model. So it's very abstract, but it's very much kind of event-driven, session-based programming. So yeah, I've posted the link to that talk in there in the chat itself. So we've got another question. Isaac, that's a great question. Over to you.
Yeah, so I've spent a lot of time poking around like OTP, and I've noticed that there's a series of modules that probably would be best described as an extension to OTP that Elixir provides. So the three most prominent ones in my mind are a task, which is a process that does one thing and doesn't have any internal control flow with messaging. And I think that the common practice in Erlang is to do a gen server that does that, which is a little bit heavyweight.
Or a process. You do a process lib spawn as well. But I'll tell you the story behind task in a minute. And
dynamic supervisor is another one that's like I would say minor. Registry is a huge help for Elixir developers. So those are the three modules I'm thinking of that would, like, I think Erlang developers could benefit from sort of a first-class, well-supported set of, like, not primitives, but built on top of primitives.
Absolutely. So I don't remember when it was, but I think it was probably 4 or 5 years ago. So I don't remember when it was, but I remember where I was, and I was actually in Buenos Aires, in Argentina, and I spent about 3 hours on a Skype call with Jose, where he went in and asked me, what would you do differently with OTP, which we now have the chance to get right in Elixir. And so I went in and I prepared, and I went through kind of all of the challenges. I think one of them was, for example, event handlers. How do you do event handlers and very basic functionality in Erlang? It's used, but it's not that well used. That's where you ended up getting, I believe, you ended up getting what is it called now? Help me, Andrea. You have with back pressure and Gen stage. Yeah, you ended up getting Gen stage. Yeah, and you got Gen stage. So that was one of the things which came out of it. I personally wouldn't have put back pressure in the behavior itself. Back pressure should probably be handled outside of your system, on the borderline of your system, not within your system, because you had complexity. But that was Jose's design decision. The other was exactly what you described, tasks. So the inability to have the inability to go in and have tasks, create tasks, because again when OTP was invented, I mean, the web in HTTP was just starting, and these were the types of things where you would get a request, you'd handle everything, you'd create the web page, and then you'd push back a response. And the way we've done it, we don't use gen servers for that. Ideally, if speed is of essence, what we would do is we would just do a process lib spawn link from the socket process receiving the request. Always link yourself to your parent process, in case these systems will run for years, and then in case you need to take down the system or upgrade it. So that was another thing. I mean, when it comes to registries, we have registries in the Erlang world. We've got so there are quite a few registries. gproc, I think, was the one most commonly used. So that's there. And again, it's not part of the standard libraries, part of OTP, but it's widely available out there. So but that said, I think OTP behaviors haven't moved a lot in 15 years. I think I think finite state machines, so Gen stage stem, is the one which has evolved the most. And what I'm really hoping, what I'm seeing right now is an influence from Elixir. You've had the ability to modernize OTP and kind of bring it into the 21st century. So it wouldn't surprise me if from Erlang now one starts using Elixir and Elixir behaviors, and hopefully they should become completely intercompatible with each other. So it doesn't matter which language, at the end of the day, which language you're actually using. Just pick the best tool for the job, and it's not a question of choosing Erlang or Elixir. It's a question of how you make them work together. And that's where I'm hoping the future will head towards, because you're solving a certain type of problem, and I think all of the knowledge from that is then reverting back into the Erlang world. So it's great. I usually joke that hey, guess what? It's payback time. You've built everything on top of Erlang, on top of our libraries. Now it's our turn to go in and start using your libraries. As I always say, together we're stronger. So hope that answered your question. Yeah. Okay, Brujo, you had a really good question.
Yeah, it's a silly one because you were very serious now. So we can agree that OTP is not the best name for this tool, for this framework. So let's say in an ideal world, you get to rename it. And what name will you choose and why?
Outlaw Techno Psychobitch. I thought that's already been decided, no? For those of you who are wondering, you need to go in and look at Erlang the sequel. Yeah, Erlang the movie, the sequel. Yeah. No. So again, this is something for a marketing department to go in and decide and pick. I'll with an anecdote. OTP is a bad name. I had my first consulting gig outside of Ericsson. The year was 2000. So one of the companies using Erlang outside of Ericsson. So about a year and a half after it had been released as open source, I went in and I discovered basically, great code, a lot of good talent, functionality, but no one had used OTP. And within Ericsson, everything we did was OTP based. So why were you using OTP? Oh, we weren't solving, we're solving an instant messaging system. We're implementing an instant messaging system. We're not writing a telecom switch. And that's where, so 2000, I opened, that's when I opened my eyes, and that's really when we started toning down the whole telecom side of things and just called it OTP. And yeah, I don't have a better name, and it's so stuck in now. But you'll see everywhere in my book, Design for Scalability with Erlang OTP. If you search for the word telecom in the PDF, it will appear once in the book. So open telecom platform, the whole expansion, it appear once in the book, and it's in a side note, which is what's in the name. Everywhere else we just refer to it as OTP. So just call it OTP as an acronym without expanding what it means. That's the choice here we've taken. Having to live with your legacy. What would you call it?
First, Andrea, then I tell you.
Okay, Andrea, yeah, what would you call it?
I know, proclib. It's like a bunch of abstractions over processes. So I'd go less philosophical, more very simple. You have the standard stdlib and proclib. I don't like that.
Yeah, that's my answer as well. I generally, when I'm teaching this, I tell people, okay, this is called OTP. It's what you know as a standard library everywhere else. Yeah. So I will call it standard library too. Yeah.
Yeah, like a functional standard library is Erlang. Process standard library is OTP, right?
Yeah, standard libraries. Yeah, absolutely. And if you ask today, I mean, what I would what I would say is also kind of OTP, the whole notion of OTP is getting a bit outdated. I mean, we should be looking at programming models right now more than libraries, and maybe maybe that start focusing on those much more than what we're doing. So okay, so let me mark this as answered. Any other questions? Any other thoughts? I mean, Andrea, let me ask you a question. When you first learned OTP, something which always surprises me is people saying, "Oh yeah, learning Erlang is easy, but OTP is so hard." And I remember teaching. I mean, the first time I taught it was 1999. I think it was early 99. And everyone said, "Oh, it's so hard." And I was struggling to understand what was so hard in learning it. And I'm wondering if it was a mental block people were having. And then people were struggling to understand the whole notion of callbacks, the whole notion of what's a client function and what is the callback function, not realizing that there were two separate processes executing them.
I still think that's
what was your
Yeah, no, it's exactly the same. I think that's still a pretty terrible mental barrier to go over, which is like, where is my code running? This is when I teach workshops about Elixir and Erlang. This is the thing that I spend the most time. Like, people get to the process of the state loop, on processes and they get the message passing, but where the code is executing is very unclear. I've always thought about this. I've never thought about how to make it better. And once you get over the barrier and you know what's going on, then it's nice that you can have like coded modules that like you can have together code that executes in the in the Gen server, for example, and code that can manipulate the answers. They can act as like a middle person between the code that you're using, the code that calls this, and the Gen server that executes the callback. But this is like by far the thing that I struggled the most teaching, and definitely I struggled with this as well when I was learning, like to understand where the code is executing, what process the code is executing. So yeah, that's my answer. You said it first, so it's the same thing.
And it didn't help. So I think a lot of the programmers I was teaching back in the late 90s were Plex programmers. So they were programmers within Ericsson, and in Plex, a thread of computation was a module. So they were struggling. They saw a module. Okay, this is a thread. This is a process, and so they were really struggling with that. And okay, I think I'm being told that time is up. Any other last minute questions just to wrap up? No. Okay, listen, thank you so much for joining us. And you catch up with us in the Toucan Lounge and other social activities throughout the remainder of the day. And enjoy.
Bye everyone. Thank you.
Bye-bye.